Alright, so this is lesson 20 of Python for data analysis, our last lesson. For today's lesson, we're going to GitHub, and this one is in Markdown format, much like the first three lessons we had, so there's no notebook to download. You can really just follow along on GitHub. And for today, I mentioned this to some of you who are here at the beginning, but you're going to want your own GitHub account. Does anyone not have a GitHub account? Okay. So you're going to want to create an account. So no pressure, but you need to think of a username. And it'll stick with you. So mine is Cuttlefish, and I still have it, and it's not going anywhere. So I've accepted that. I mean, I embrace it actually, but so you're going to want to, if I were to open up a new browser here and go to GitHub, you go to sign up, or actually you can do it right here. Just pick a username. And it'll tell you if it's already taken or not. So think about what you want your username to be. You can always change it, especially if you just created it today and you don't have like a history of. What happens is it's like any other social media, where like Twitter, for example, where people will tag you in like certain software projects, and so your username will be linked to your identity. And so if you're just starting out, you can change your username and it'll be okay. But over time, you don't want to change your username. So pick something you like, give an email address and a password. The email will be used to contact you if there's any changes to your repository, or somebody else mentions your name, mentions your username. And yeah, so to go ahead and do that. And we will use those in a minute. Okay, so Git and GitHub are kind of work hand in hand. So GitHub is a code hosting platform for version control and collaboration. And so it lets you and others work together on projects from anywhere. And then the version control system, or VCS, that it uses is called Git. And Git is responsible for, in particular, how things work on your local computer, and for managing any kind of differences between files as you change them. So in the simplest use of Git, you create some code or data that you want to host. GitHub will not let you host a lot of data unless you pay extra money. So you can't put like massive data files on there. You want to host those somewhere else, but your code is typically not huge files. So you can host your code for free. So the simplest example would be you have some code that you want to make available. Say you published a paper and you had some code that you used to analyze your paper. You can publish your code on GitHub, and other people will be able to see it. So that would be the simplest example. You just push your code to GitHub from your local computer, or you could even do it all on the web. The next, like, more complicated would be if you were going to then make changes to your code. You could make changes and then push those changes to GitHub, or you could create a branch of your code where you're going to make some changes, and then eventually you merge that branch into your main code, and that merging can be done on GitHub. But the real reason that GitHub exists is for collaboration. So it doesn't just track versions of your software, but it also allows you for multiple people to work on multiple different versions of code, and then to eventually merge those into the master code repository that everyone is using and looking at. And so it allows you to keep track of all the different versions that people are working on. And for example, if you want to develop on a project, I mean, there are some really sophisticated projects out there that you can clone the whole repository to your computer, and you can work on it, and you can change things. And if you get something cool working, you can issue a pull request, and you can say, "Hey, I came up with this thing," and people that manage that project will review your code, and if they like it, they can merge your code into the repository. So this is a way that you can really do some cool collaborative coding. But today we're not going to do any big software projects. We're just going to show you the basics of how you're going to create a repository and make changes and stuff. So the first thing we're going to do is talk about the GitHub Flow. So this comes from GitHub Guide. So if you do a command click, it'll open up a new tab, and you can see the GitHub Flow. So I like this visualization, so we can look at this. So in the first step, you're gonna this is kind of the more full flow that you would use if you were actually going to take a repository and create a branch. So a branch is where you're going to work and develop new things on the project. So when you make changes and you commit those changes, you're committing them to the branch, and that doesn't affect the master branch. So you take this this code, this kind of going from left to right in time. You take this master repository, and you're going to make a branch. So it just says here. It just says that the master branch is always deployable. So the master branch should always be fully functional. Anything that's in there should be tested and make sure that it will work for the users. Okay, so the next thing is you have your branch. You're going to add commits, and so what this means is that you're going to edit files, run the code on your computer, make sure it works when you edit those files, and once you're happy with it, you're going to add those files to a growing list of files that you've added to Git, and then you're going to commit all those files. So you're going to commit those changes, and all of the editing and the committing can be done offline. So if you're on an airplane, or you're in the middle of the desert or the jungle or whatever, and you're writing code, you can still make changes to files and commit those changes, and then once you're back connected to the internet, you can push those changes to GitHub. So a lot of this stuff is, we're all talking about what you would typically do on your local computer. You then open a pull request. So this is telling other people that work on the repository, hey, I made these commits, I made these changes to these files, and then they were part of these commits that did these certain things. I'm opening a pull request where I'm requesting that you pull my changes into the master, which is going to happen later. It doesn't happen right away, though, because there's a discussion period where somebody's like, yeah, I reviewed your pull request, but I noticed that you didn't follow the PEP 8 standards, or those style standards, or you wrote the same thing like 5 times. You could have written a function that did it, and then you just used that function. Or this isn't working on my Linux operating system. You must have something that's only working on Mac. You should fix that, etc. So you say, oh, I didn't know that, and then you make changes to your local fork, or rather your local branch, and you then make more commits. So once you open a pull request, you can still make more commits to that that branch. And then there's a squirrel, and the squirrel will test your code before you deploy it. So so you can deploy the code from a branch for testing. If you this is kind of more for a big software project. So you can deploy the code to make sure everything works. It's deployable. Once everything is happy, the people that manage the project are happy that your code is deployable, then it can be merged. So you merge that branch into the master branch, and you can typically you can delete that branch, and then you can start a new one to do more. So if we go back to our Markdown file, we have the same information here that I've summarized. So we create a branch, we add commits, we open a pull request, we discuss and review your code, we deploy if necessary, and then merge. And if you were fixing an issue, you could say, I fixed this issue and I closed issue number 45. So all the issues, we'll talk about issues in a minute. All the issues have numbers and that are sequential. You can tag those with a hash sign, just like you can tag a person with an @ sign at their GitHub ID. So the other GitHub terms I wanted to talk about now are a repository. So this is a project on GitHub. It's called a repository. This encompasses all of the files and folders with the project, along with each file's revision history. So if you guys are familiar with this because this Python for data analysis is a repository. And at the top here, it's listing all of the files. And each of those files, so if I click on the schedule, it has a history. And I can see all the things that were done. I can click on the commit number and see that I changed this link here, and I changed this here as well in the README. So you can go back and see all of the things that have been changed. So let's go back to lessons, lesson 20. The next term is clone. So when we clone a repository, we are creating a local copy of a project that exists remotely. So if you wanted to, you could clone the repository for this class to your computer, and instead of having to copy each lesson every week, you could just open it up and you could pull updates. I know some of you have done this actually, clone the repository for the class, and just the issue is with that is that you just need to, instead of copying that new lesson every time we do that at the beginning of class, you would do git pull or git pull upstream master, which would be my master copy. You would pull that to your computer and it would update all the changes that I had made. It would update your local copy. That's a little overkill for this class, but you could do it. That's the idea. So anytime you want to clone. The other reason you would clone is if you want to just use someone's software, which is on GitHub. You don't want to make any changes, but you just want to have a copy. You can clone it to your computer, and that's basically like kind of that might allow you to install the software or run it on your computer. The other term is issues. So issues are tasks in the project that need work. So issues are either open or closed. So when they're open, they still need work. They start out as open, and then once they're solved or fixed, the status is changed to closed. But you can still see what was done on that issue. So you can assign someone to an issue, and you can mention them as well, and they'll find out about it. So if we again, this time I'm going to command click so I don't lose my space here. I'm going to command click on the close that one, I think. Command click on that. So now I got another copy of this tab here. I can click on issues. Right now there aren't any open issues. There's one closed issue. Have students fill out the survey. I can, if I wanted to create a new issue, I could say, here's a new issue, and I could say, I could reference existing issues with that %sign. So I could say, this was a previous issue, and I could say I want to assign someone to it. I'm the only contributor to this repository, so I'm the only one I can assign to it. But I could assign myself to it. I could add some labels, projects, milestones, various other so it could be part of a bigger project, or there could be some project milestones. This is more for developers. And then you could submit the issue. I'm gonna, and this also supports Markdown, by the way, so I can write a list. And see if there's a way to preview. Yeah, so if here's writing and here's preview, so I can see now this is what it would look like if I posted it. So I see I have my items here, and then I have this issue, and this is linked. So it links to that that previous issue. So it's all really nice. But I'm going to, I'm not gonna. I just navigated away, and so I didn't actually create that issue.
So if you want the newest version of the master sheet, do you have to pull it, but it won't auto-update?
It will not auto-update. If you want the new version of the repository, you would have to pull anytime you want to do that. But if you're working on your own branch, then maybe there is a way that you can pull updates, but there might be conflicts with what you've done, so be aware of that. Let's see here. Okay, so a few more kind of vocabulary kind of things. So there's some.
Sorry, I guess I'm just confused with is the difference between Git and GitHub, and when you're cloning something, is it's actually on your
Yeah.
line and on your.
Yes. So when so Git is the software or the program that handles all the version control and the pulling content from the web and pushing it back up and keeping track of your commits and all that stuff. GitHub is the web interface that makes it all work, because so when you clone a repository, you're going to clone it from GitHub. We'll see that in a minute. And it's going to make a local copy, which now it could just be it will have the ability to make changes and put them back on GitHub, for example, but it doesn't have to. It could just be a local copy.
And you need to actually you need to download Git and not just GitHub. Have a GitHub account to be able to do that.
Yeah, we're gonna install Git in a minute. If you, I think it's in this next step. So we're gonna do. I'll do a little more vocabulary, and then we're going to do an example on the website itself, which does not require Git on your computer, and then we'll do an example, actually several examples where you do need Git on your computer, and we'll install it if we don't have it already. Okay, so this comes from, again, I can command click and see the Git handbook talking about what all these things are, but I've condensed that here. So so if you have there's different versions of Git that you can use. You can use GitHub Desktop or Git Kraken, or I think Git Bash should work too, but maybe some of you are still using Git Bash if you're Windows users. For Mac users, you can download Git and run it from the terminal. So Git init, we'll see that one. That initializes a new repository and then begins tracking it. So it creates some hidden a hidden subfolder that tracks all the changes that you've made. Git Clone, we talked about that. This is so these are actual command line commands that you would type. Git Clone creates a local copy of the project that already exists remotely on GitHub, and the clone includes all the project files, history, and branches. Once you've initialized or cloned a repository, those are usually alternatives. You don't do both of those. You either create your own new repository or you clone an existing one. You then there is some there might be a little bit of setup that we'll see, but then you can start making changes to files, and once you've made a change to a file, you can add that file. Or if you've copied a file into your repository and you want to add it, you can type git add and then the name of the file. So that will stage the change, and it will then be ready to be included. And you can unstage things. There's a way to do that. But there's a related command called git remove, which is git rm, which would delete a file from your repository and also tell Git about it. So otherwise, if you remove a file, you still have to tell Git. You have to actually add the file that you removed to make it register it. Then finally, once you've added all the files you want to add, all the changes, you're going to commit. So you're going to type git commit, and this will take a snapshot of the project history and complete the change tracking process. And you also specify a comment that will be associated with that commit. So when you type git commit, you'll type then, if you don't type anything else, it will bring up your favorite text editor, and you will have to type in a description of what that commit is. Otherwise, you can type git commit -m and then after that a string in quotes that says what your commit does. You only want to commit once you've come to a stopping point where you're kind of happy with how things are and you're ready to stop and kind of summarize what you did. When you want to see what's going on in your repository, what you've added or removed, or if you have changes that are staged or unstaged for commit, you type git status. We'll see that in a minute. Git branch will show you the branches that are being worked on. Git merge will merge lines of development together. And there's a couple other commands. There's one called git diff, D-I-F-F, which will get the difference of two files. I will add that after class. And finally, the big ones are also git pull, which will again, this will update your local copy with its remote counterpart. So if you're working on master locally, it'll update from the master. If you're working on a different branch, you can update from the branch. And then finally, you can push your updates locally to GitHub. And if you're working on a branch, it will push it to the online version of the branch. Or if you are working on master, like in the simplest case, you're not collaborating. You're just sharing your code with, for your own records, or maybe for a paper that you're writing, or for me for this class. When I edit the files for this class, since no one else is working on this repository, I'm working on the master branch. So when I make changes on my computer and then I push them to GitHub, those get pushed to the master branch, which means you guys would see them right away. I don't have a separate branch that I then will merge with the master, because that's an extra step that I don't need since I'm the only one that works on this repository. So there's a full reference guide here to more Git commands. And so let's take a quick break. We'll make sure everyone's got a GitHub account and that you have Git installed.